This is part 2 of the neural network, and I already uploaded the neural network.ipynb file into Canvas. Go ahead, download that one. And before going further in this video, make sure that you watch all of the Python videos, and because if you haven't watched the Python videos, you're going to be kind of confused right now. And the other thing is you should also watch the neural network part 1 video. This is part 2 video. In this video, I'm going to show you an implementation of a neural network. Particularly, we are going to be building a deep neural network. Like this is simply a deep learning. Let's get started. And once you download this file, neural network.ipynb from the Canvas, you can go to File and then go to Upload Notebook so that you could have the same material with me. At first, we are going to, let me explain this machine learning process one more time. At the beginning, we are going to acquire data. Then we are going to prepare the data. And we'll split data into two parts, testing and the training. And we are going to build the model on the training data set. And we will use the testing data set to make predictions and see how it is working and so on. And all the way to the end, we are going to be implementing the model. Let's go back and let's do this one in Google Colab at first. And I'm going to be importing the pandas. This is why I'm just going to click on this icon that says run cell so that they are going to be important. Next, I'm going to be reading the data set, and let me explain what it means. And so far, all of the data sets that you have seen, or all of the data, is built by me. And the idea is that in general, a data engineer is going to give you data set. And this could come from companies' databases, Excel files, and so on. And in this case, we're going to be working on a file called regression.csv. And let me show you the file. Let's go back to downloads. And you can get this data, regression.csv, from the Canvas website. Let me explain this data set. And the idea is that we have two features, and features are simply the things that we use to make a prediction. And by using those two features, we are going to make a prediction for the price. And this is a very simple data set. The reason is that I don't want, because normally, like whenever we build neural networks, it may take like a couple of hours just to build the model, just to run the neural network in the background. And I just want to build a simpler one just to explain you what is going on. And you can just think about the features, something like your height and weight. And then let's say we're going to predict something. It shouldn't be price. But let's say we're predicting something price. Or you can just think about this way. This could be how big the house is, and the feature two could be number of bedrooms in the house. And we are trying to predict the price of the house. And you get the idea. And the issue is this for us. The important thing is this, basically price. And we're just going to build the model. And you can just think about this a loan application for a credit card, or loan application or credit card application. And everything about you, like your credit score, your previous balances, and so on, will be features in that model. And all the way to the end, it's going to make a decision about whether to give you a loan or not. But in this particular case, I give this a file name regression.csv, because what we are predicting is a numerical value. It's not 0, 1. And I'm not predicting the eye colors. I'm predicting a numerical value. That's why this will be a regression problem. Okay. And here's what we're going to do. At first, this is not able to, right now, it's not able to read your regression file. And the reason is this: in your case, you haven't uploaded the regression.csv file here. Let's do it. And the idea is this Google Colab environment is not just like a one interface. It's actually a virtual computer running in the Google servers. And we could just upload the files over there and run this thing. And click on this icon that says Files. And once you click on that one, this will probably take a couple of seconds for you to refresh. You're not going to see the My Model H5 or regression CSV. You'll only see sample data there. And here's the way to upload a file over there. Right click on a white area and go to Upload. And then choose the regression file. It's going to rewrite mine. And this is the way that you're going to upload the files into Google Colab. And from now on, I should be able to read this file. And the way that you're going to read, I'm going to read this is going to be pd.readcsv. PD is short for pandas. Readcsv is a function inside the pandas. It basically means go ahead, read this file, and then put it into DF. Okay. And let me explain the data frame so that you have a better idea. I'm going to say df.head. This is going to tell me the first 5 rows in the data set. It basically means it's just getting the price, feature 1 and feature 2. If I open it side by side with my own version of the regression, you're going to see this is going to be the first few rows of the data set. Okay, let's close it. And it's always a good idea to look at the end of the data set too, because if there's something wrong when it is reading the data set, it's going to show up in the last 5 or 6 rows. The df.tail is just going to show you the last 5 rows. And if you see the number, it's 999. It basically means we have 1,000 rows. And this is a fake data that I just built. Like, the reason is that I just want to show you how the neural networks are working. And whenever you get a new data set, you should always look for the info too, df.info. Info is going to give you more information about this data frame. And it just tells you we have 3 columns, price, feature 1 and feature 2. And we have 1,000 rows. And non-null simply means there's no missing value. And data type is float 64. It basically means this is like the data is just in, the data has a decimal points. And other than that, I'm also going to run df.describe. Describe will give you basic statistics about the data frame. It's just going to tell you the mean, standard deviation, and so on. And if you look at it, the mean for the price is around 498. That's totally fine. In the meantime, let me show you how to create some charts and so on. And by looking at this data frame, let's have a look at how the price is distributed. Okay, I'm just going to say df price. If I do this one, it's just going to give me the list of the prices. And I'm just going to use a function called plot. This plot is part of the data, like a pandas. And this description is super difficult to grasp, but let's do this one. The kind is simply what kind of graph that I want to have. I want to have a histogram. Let's run it. And it's going to build the histogram on its own. And you can change the number of bins with the bins option. Let's put 20. And this looks like it's normally distributed. Okay. And I should do the same thing for the feature 1 and feature 2. Actually, I will just do it for feature 1 just to show it to you one more time. It's basically, I got the feature 1, click and then dot plot. And I am going to say this is going to be histogram. Let's leave it with the default number of bits. Okay, this also looks like a normal distributed variable. Okay, and the reason I'm looking at those stuff is this: in machine learning, especially in deep learning, I have to understand how data is distributed. If it is skewed, I need to do something about it. This is going to be the part of data preparation. I already know those 2 features. Let's do the df feature 2 too, so that you understand. I'm also going to look at the feature 2 dot plot. I'll say this is basically the kind of graph that I'm going to building. It's a histogram. Let's build it. This also looks like a normally distributed. And the reason is this: I want to make sure that it's not going to be skewed. And the next stage is simply data preparation. And let me explain what it means. In data preparation, we deal with the missing values. In this particular case, we have no missing value because I run the df.info. It just tells me non-null, and every single row has the data over there. And in this stage, we also do some kind of data crunching. It basically means sometimes we convert the variables based on whether they're skewed or not. And this is the part that we just make some change in data sets so that it will be ready for the neural networks or any kind of machine learning algorithm. For this case, I'm just going to, we actually have no data preparation, meaning that the data is already clean, it's ready for analysis. And the other thing that we do is this: we just split the data into 2 parts, and these parts are going to be testing and training. And let me explain what is going on over here. I didn't run it. The issue is this: just think about this way. This is my data set in kind of Excel. This is not Excel. I'm using a Mac, which doesn't open the Excel automatically, but if you open in Excel, you'll get the same thing. And the idea here is this: if you scroll down, I have 1,000 rows. I need to make a split over here for training and testing. And with the training section of the model or data set, I'm going to build the model. With the testing, I'm going to test it out. Okay. And here's what we are going to do. I want to go get the X values. X are simply the inputs to the model. The X is simply feature 1 and feature 2. And what I'm going to be predicting is the price is going to be Y variable. And here in general, what we do is this, we create those variables like X and Y, uppercase X and Y. This is the notation that we use in neural networks or in machine learning in general. And let me explain what this function is doing. At first, I'm going to go grab those two columns, feature 1 and feature 2. And the notation is a little bit difficult to grasp. For example, when I'm just looking at only one feature, I just put it in like this. When I have more than one feature, I have to put it into a list. That's why. And if you look at the DF feature and feature 2, it basically means I'm just going to get those two columns. And the problem with those columns is actually this is not a problem, but the issue is this is a data frame. Okay, let me explain what it means. If you search, if you wrap this around type, this is going to tell you it's going to be a data frame. And we are going to use a special library called TensorFlow to build the neural networks. And those TensorFlows will not be able to work with the data frames. I need to convert this data frame to a NumPy array. That's why all the way to the end we say values. Values simply means go get the actual values, forget about the column information or anything else. And the idea here is this, remember I told you about this before, the NumPy arrays are going to be running quite fast. That's why we're converting into a NumPy array. If you wrap this around the type, you're going to see it. This is going to be a NumPy array, okay? And this is what we do here in the highlighted part. In the second highlighted part, I'm creating the Y variable. This is something that I'm going to be predicting, okay? Let me remove this line that I just built. And the next line here, what we are doing is we are creating a split between training and testing. And over here in the highlighted part, I'm just trying to use a train and test split. And you don't need to remember how this is going to be done. In general, I don't even remember. I just copy and paste the code. And over here, it simply means the input for the train test split function is my actual X and the Y. The test size is going to be 0.3. It simply means get the 30% of the data set is going to be randomly assigned to the testing, and the remaining part is going to be assigned to the training data set. And state 42 here is just like a make sure that you have state 42 over there too, so that we both end up with the same training and testing split. And this is done randomly, but when you say random state 42, every single one of us will have exactly the same split. And on the left side, we have X train, X test, Y train, Y test. You might be thinking that we split the data into 4 parts. No. The idea is this, every single row in the X train corresponds to X test 2. And let me explain what it means. Let's run it, this one. Let me show you the first row in the X train. Okay. This is an array of size 2. This is feature 1 for some of the rows in the training data set. This is feature 2. And if you look at the X test, or actually Y train, I'm sorry. This is going to be, I should go get the first value there. It simply means for those two features, this is the corresponding price in the data set, okay? And the idea is this, actually they are going to be moving together. And just think about, let's go get the first 10 here. And let's go get the first 10 here. The data is going to, this training data set is going to move into the neural network. And then, let's do it correctly. I put the, and then, for example, we want the neural network to make a prediction for those two values. And then we're going to tell the neural network, oh, the actual value is 461, okay? And we are just going to do this one for every epoch. Epoch means that we are going to pass the whole training data set, and then we'll give the neural network the actual Y train, and it's going to go back and then update those weights on their own, okay? And the reason we split data set to parts, training and testing, is simply we want to test the data set with the data that it hasn't seen before. And right now, once I make this 30% split here, it basically means the neural network will never know anything about this X test and the Y test. I'm going to use it later, okay? Now let's go get to TensorFlow and let me explain what TensorFlow is. And in the past, we used to have lots of difficulties building the neural networks. The reason was that we need to code this whole thing. And right now the code is super simple to understand, but in the past we have to write every single function and so on. And what happened is this: Google engineers just provide us with something called TensorFlow. That's basically a neural network library that we use that makes life super easy for us. And actually, even on top of the TensorFlow, we have something called Keras that you see here. The Keras is another abstraction layer on top of TensorFlow. With TensorFlow, tensor simply means the matrix. This is simply a matrix kind of multiplication models and so on. And right now I'm going to go get the sequential model and from the TensorFlow models. It basically means I want to build a feed-forward neural network. Feed-forward neural network means everything moves from left to right. Once we acquire data in the input layer, everything is going to move to the right slowly, okay? And the dance and the activation simply means that these are going to be layers that I will be building, and these are going to be hidden layers that I will be building. And activation is the function that will be used on those like neural networks, in those like activation functions, okay? And remember the TensorFlow playground. Let me show you over here one more time. Okay, remember we were trying to solve this problem. Let's run it. Okay, and here's the idea. The data that we are going to be passing is going to be very similar to x1 and x2, but we call them as feature 1 and feature 2. And right now I'm going to be building a neural network with 3 hidden layers. In every hidden layer, there will be exactly 4 neurons. Okay, let's build this thing from scratch. And this is what is going to happen. And right now, this is a classification model. It basically means it's predicting the orange and the blue data points. I'm not going over this one more time because I already covered this material in the neural network part 1. And if you have any questions, go back to that one and then watch that part of the video. And which basically means this is the model that I'll be building with 3 hidden layers. And the question that you might have is why 3 or why 4 neurons? I mean, I just picked up randomly. You can do whatever you want. And the idea here is this: there are different activation functions, and remember those activation functions are going to be working on the squares, and once it gets the value, it's going to convert this to another number that it will be passed to the right. The ones that you see over here are called weights, and I'm not going to be dealing with the weights. It basically means the weights are going to be initially random, and after each epoch means all of the data set will move through the neural network once. It's going to make a prediction for every single row in training data set. And I'm going to show the neural network actually is going to be done automatically by TensorFlow. And the TensorFlow will look at the actual values with the predictions. And if the error is over there is very high, it will go back and update those weights with an algorithm called backpropagation. But the issue is this whole thing is hidden from me. The only thing I need to do is just to import this data, import this like a libraries first, and then build the model. And let me explain what is going on over here. Right now I have something like model equals sequential. It basically means, and remember the sequential library or method that I go get from there, it basically means this is going to be a feed-forward neural network. And once I build the model, okay, and the model is empty right now, I'm just going to say model.add. It simply means I'm adding a new layer to the model, like this one. And remember, this is going to be the first hidden layer. It has 4 neurons. This is what it means. Dance 4 means create a neural network with 4 neurons. And the activation function is a special function that we use called ReLU. It simply means this is the way that it's going to do the computation inside this like a neuron. And the second one that I just highlighted here basically means I'm going to be creating the second hidden layer. The third one simply means I'm going to be building the third hidden layer. And you may be having questions like, why didn't we build the input part of the things? This is going to be handled by the Keras library and TensorFlow. That's what I'm telling you. The life with the TensorFlow and Keras is super easy. You just write few lines of code and boom, you have the neural network. And all the way to the end, this is going to be the output layer. That's not output node. Let's give the name output layer. And over here, I'm just not going to have any activation function because this is the part that is going to be making prediction. There is no activation at all. And this is the way that you're going to add. And all the way to the end, you see the model that compile. It simply means I need to tell the neural network what it needs to optimize for. And over here, the loss function is called MSE. MSE means mean squared error. And the idea is this. Let's open this thing in Excel so that you understand. Because I'm going to do some kind of calculation. Don't convert. And the idea is this. This is the actual price. And right next to the actual price is going to make a prediction. Okay. Let's say in the first iteration, it thinks price is 500 here. And then the neural network is going to calculate an error that it's making. Error is simply the difference between the actual value and my prediction. Okay. It basically means for this guy, it's making 38 points error. And it's going to do square of those errors. The reason is that some of the errors are going to be positive, some of them are going to be negative. By just squaring them, what we are doing is this, like I'm just taking it to the power 2. We are going to make sure that every single error squared here is going to be positive, okay? And then I'm going to add up all of the errors. That's not what I'm going to do it manually. It will be done by the neural network. And then it will find out the average error. Mean square error simply means this is the total number of errors it's making. And the idea is this. We want the neural network to make a very low error. It basically means look at the prediction 500. And if the error is gigantic, it's going to go back and then change the weights in the model. Okay, the weights over here. So that the next time in the next iteration called next epoch, the error will, for example, move from 500 to 495. The error square will get lower. Next time it will be 493 and so on. Okay, and it's not just like a one row that is going to be making those changes. It's going to consider all of the data set in the training part of the training. And remember, we have 1000 rows. It basically means this is going to do it for 700 rows. And mean square error simply means the total error is going to be making. Okay, and this whole thing is hidden from us thanks to TensorFlow and Keras, and it will do it over there on its own. And all the way to the end, this is a section that we are going to be doing the training. This is the part that we are doing right now, the one in the middle. Okay. And once I click on this, and by the way, let me explain this one I forgot to tell you. Let's look at the part that I just highlighted, model.compile. Over there, we just tell that this neural network is going to be optimized for mean square error, MSE. And there's also another function like optimizer equal to RMS prop. It basically means this is the algorithm it's going to use for backpropagation. And backpropagation is simply the algorithm that is going to be used to update the weights. Okay. And all the way to the end, I'm just fitting the data. I'm going to provide the X train and Y train. And the epochs equal to 150 means, okay, pass the whole data set through the neural network 150 times. After each epoch, it's going to calculate the loss function. Loss function is simply the total error it's making. Okay. Let's run this one. If you look at it, the error is gigantic all the way to the beginning. But as we pass more and more data, the error is going to go down quite fast. Okay. And right now, what I skipped is this. Normally, we have to optimize this neural network. Basically means like I'm trying to figure out the optimal number of layers, optimal number of neurons. And then I'm also going to run this thing on the prediction data set and so on testing, which basically means I'm skipping the parts over here testing data and then going back to the model training and so on. This is like a very iterative process, meaning that I will go back and forth and change things and so on. But I already did it before and I'm not showing you the a part because this part is more like an art and it's beyond the scope of this course. I just want to make sure how these things are being calculated. That's it. And which basically means that I'm not actually showing you how to do the model testing because it's going to be super difficult it will be like almost like a PhD level course. That's why I'm skipping it. Okay, but if whenever you hear the term machine learning engineer in the LinkedIn or job description, these are the people who are going to be spending their time by just calibrating those models and so on. Okay, and let's say we built the model, and I told you that let's say feature 1 is 1, feature 2 is 1. Use the model to make a prediction. Okay, let's do it. I created a data point, and this one is in double, like a array, it's 2-dimensional array. And the reason is this: originally that our training data set is in 2-dimensional. That's the reason. I'm just going to say model.predict new data point, and I'll get the answers over there. Let's say the actually feature 1 is 0.5 and feature 2 is 0.8. It could also make a prediction for this one. This is the new data point right now. Now it's predicting 603 for the price. Okay. And this is all for the neural network. And for your assignment, I'm going to give you a new data set, and I will give you the whole template that you could run. And the only thing that you're going to do for the assignment is to just upload the file. Remember the part that I just uploaded, regression.csv. Basically means click on this icon, right click on, go to upload. This is the way that you're going to upload the file. And you don't need to change anything in the assignment for the first couple of parts. I'm just going to give this whole thing in just one block. Basically means that, for example, look at this one. I have 2 lines of code, but I just created multiple lines over here just to explain you the things. I'm just going to give you one block, and all the way to the end, I'm going to give you the features that you should be making the prediction for. Okay? And thank you. And if you happen to have any questions, shoot me an email. Have a great day. Bye-bye.